We want to solve the inhomogeneous equation r dq dt plus q over c equals v, with the initial condition q equals 0 at t equals 0. This is an equation describing an RC circuit of the type you can see drawn, and to solve this we're going to use the method of variation of the constant. The first step in this method is to solve the homogeneous equation, which we get by setting the right hand side of the equation equal to 0. So the homogeneous equation, that's r dq dt plus q over c equals 0. And we solve this by putting all the q's on one side and all the t's on the other. So dq over q is minus dt over rc. We can integrate each side to get that the natural logarithm of q is equal to minus t over rc plus the constant of integration, which I'm going to call a. To isolate q, I'm going to take the exponential of each side. So q is the exponent of minus t over rc plus a. But this isn't quite in the form I like, so I'm going to replace the e to the power a in this by a different constant I'm going to call b. So my final solution for the homogeneous equation is that q is a different constant b times e to the minus t on rc. Now in the method of variation of the constant, the way I find a solution to the inhomogeneous equation is by replacing the constant b by saying that b is a function of time. So I'm going to say that for the inhomogeneous equation, q is b of t times e to the minus t over rc. And I'm going to substitute this into my inhomogeneous differential equation. But before I can do that, I need an expression for dq dt. So using the product rule, dq dt is b minus b over rc e to the minus t over rc. That's u times dv dx, since we're using the product rule, and then that will be v du dx. So that's plus db dt e to the minus t over rc. So I want to substitute these into my differential equation, which is r dq dt plus q over c equals v. So that gets me minus rb over rc e to the minus t over rc plus r db dt e to the minus t over rc plus b over c e to the minus t over rc all equals v. So I see I can cancel the r's, r and r, and then I can cancel the b over c e to the minus t over rc terms. So what I'm left with is r db dt times e to the minus t over rc is equal to v. this is a separable equation. So I end up with dB is V over R e to the minus t over R, e to the plus t over RC dt. I'm going to integrate each side to get that B is V over R times RC e to t over RC plus a constant of integration, which I'm going to call d. Some cancellations, and cancel the r's. So this is CV e to t over RC plus d. And I'm going to substitute my expression for V into my expression for Q. So Q was equal to B times e to the minus t over RC. So now I know what B is. That's going to tell me that Q is CV e to t over RC plus d all times e to the minus t over RC. I can multiply this out and use the fact that e to the plus t over RC times e to the minus t over RC is 1. So that's going to give me Q is CV plus d times e to the minus t over RC. My final step is to make use of my initial condition. Q is equal to 0 at t equals 0. So that tells me that naught is CV plus d times e to the minus 0 over RC, which is just 1. So that tells me that d is minus CV. So my final answer is that Q is CV minus CV e to the minus t over RC, or take out a factor of CV, and that's my solution.